Implementation of, or UDOT's implementation of Bentley SUDA, if I can get things set up right. I'm Bob Peterson. I work for UDOT. I've been working for UDOT for about 26 years. 20 years as a registered professional engineer. Got familiar with the CAD and came over to the CAD support group. Right now we're called, we've been a lot of different names. Right now we're Technology Advancement Group. Our group used to be about 9 people. I mean, now we're down to Jim, and well, Jim Buckley has been pulled off onto standard drawings. And so it's just Paul and I that are doing the CAD support. And that's why yesterday in our session, it was asked when are we going to do the element templates, and who knows? Who knows when one person can get things done, because Paul's concentrating on the surveying and LiDAR and all of that work. Survey codes, he's had that on, it's been a year, hasn't it? About a year. He's had that on his list of things to get done so that the surveyors can get information out and get your codes loaded up in your system. But we're just pulled in so many different areas that we don't get that done. We have sign-up sheets. I'll have Paul start this side. Make sure you get your name on these so that you can get credit for attending the class, get some CEU credits. This one is available for credit. If you're from out of state and you need the continuing education credit, they didn't do this yesterday, but we've got forms that you can fill out, and then I can sign them to verify you're attending the class. And so those are up on the desk, so you can do that after. Can't think of anything else that housekeeping needs to be done. I think that's about it. I'm going to be seated in most of this. It's going to be a live demo. Well, I'll kill you with a few PowerPoints, but then we'll switch to a live demo. So cross your fingers, live demos never work. We might do a lot of talking if the computer doesn't work very well. So I'll switch over, and I'll be seated down here. And we'll see how, I have no idea how long this is going to last. All right, I put a disclaimer on. I'm not a Bentley representative. A lot of people think I am, that I'm pro-Bentley. It's just I'm so submerged into Bentley's setups and configurations that's my life at UDOT. And so try to do a disclaimer. Whenever you see those public opinions or info commercials, they always put a discredit saying the views don't represent the company. And so I was trying to get that. Just so everyone knows what SUDA is. SUDA is the Subsurface Utility Design and Analysis Tool. It came out, I believe, more than a year ago as SU. When the EDC was promoting the 3D design, they were looking for utility applications that would do those 3D representations. So Bentley was working on SUDA, and they quickly released the SU part. They had that developed and was ready to go, and so that's the difference between SU and SUDA. The SU application we've had for a while, since SS3. Now, since July, they've released the SUDA. It's for the purpose of planning, design, decision-making, and hydraulic design. It'll do pipes, cables, ducts, all sorts of, anything underground, they're doing it. And I'm also trying to get it so it'll do above ground. I think this tool will give us some extra 3D functionality, and I'll show you that a little bit later. The full SUDA was released in July 10th with the 8.11.9.845 release. UDOT has licenses for the SU. The SUDA is broken up into two different licenses. One's for the utility database that's put into the file, and one's for the hydraulic that's in the file. The hydraulic comes with the application and allows 100 inlets. So if you have a network that's 100 or less inlets or nodes, just having the application loaded, you have the license for it. If you need additional functionality, if you got more than 100 inlets, if you want to do more than what the standard does, I believe like a pond functionality that Civil Storm will give you, or just additional functionality, UDOT has additional licenses. I don't think we'll need to use them very often, but we've got 2 StormCAD Unlimited, so if you just need to enhance the storm drain design and you have more than 100 inlets, you can load up the StormCAD Unlimited and put in all your nodes. So we have licenses, we have 2 licenses for that, and we have 8 Civil Storm licenses. Civil Storm is a little more intense hydraulic design, so those functionalities there. And we have 53 SUE licenses, so that should be plenty. We're not even using more than 50 inroads licenses, so that should be plenty to get our subsurface design done. The SUDA functions off of databases that are built into the DGN, a SUE database and a hydraulic database. I will not be demonstrating the storm drain design portion of the SUDA. We have not set up our standards into the program. So we don't have UDOT design standards incorporated. That's on the chart to be done. And I don't know when that'll be done. I need to get together with Central Hydraulics and the Region Hydraulics, and Jeff had mentioned that he wants to bring a couple consultants in that do a lot of drainage design for the department and get them in and get all of the drainage standards established. It involves having a seed file. There's a lot of things, prototypes that need to be set, established. Our nodes need to be defined correctly so that they come in. It knows what size of inlet it is, what the capacity of the box. So all of those design standards need to be established. For the majority of the SUE cells and lines and conduits, I've had in a testing environment. So the 215 projects had access to them. Most of the projects that are advancing in the 3D have had access to them. But after the conference, I'll release an update to the CAD standards and push them to the live. The thing to know about that is they're continually changing. There are so many utility nodes and conduits and different types of things that need to be developed. They will constantly be changing. And so just be aware of that. I'll show you in that functionality. I've also been seeing a lot of confusion about cell types. Now with the open roads, we have 3 different types of cells that are being referred to. We have our normal 3D cells that have always existed. We have the SUDA cell, which has a little bit different functionality. The 3D cell, you can snap and input a location. It's all based on the cell origin. You can assign a pay item to that cell. So if it's a unique cell and represents one single pay item, or it could hold 2 different pay items in the quantity database. It could be the foundation and the sign, or different things. If it has that, we can put that attribute in the cell, and it'll pick up the pay item for your quantities. If you place it, it has to be done in the 3D model, and it has to be in a top view orientation. So the cell, as you place a 3D cell, it's going to take the orientation of your view. And so make sure you're in a top view. And if I remember, I'll demonstrate that also. A SUDA cell is a little bit different. It's comprised, the SUDA cell is made up of 3 different cells. You have a top isometric or 3D cell, you have a bottom 3D cell, and planimetric cell. So how you want to represent that element in 2D on a paper or whatever, you also create a 2D cell for that representation. Elevation is based on the reference element, and that's what I like about these pseudo cells is you can snap to an existing terrain or to a top surface, and it will give you the elevation, top elevation of that cell will take whatever elevation you select for its location. And so that's where the power of the pseudo cell is it can automatically place your elevation. You can also key in an elevation. The top 3D and the bottom 3D cells merge together. You can decide in your application and your preferences if you want the bottom cell to extrude upward or if you want your top cell to extrude downward. So based on your invert elevation and your top elevation, your cell will extrude to fill in that gap and create a single cell. And I'll demonstrate that. And you can also place these based on with Civil AccuDraw. I believe all the cells you can place with Civil AccuDraw and do a station offset placement. There are different things that are defined in that pseudo cell that tell it the orientation, the alignment, where the top elevation is measured from, where the invert elevation is measured from, where pipes come and connect into that cell, and I'll show you those. If you have an element that you only have one cell, I'll show an example. I have a ramp meter signal pole or a sine cell. We don't extrude an invert and a top elevation, so I have them all in one cell. And so if you do that, you define your feature as a bottom cell, and then it'll just place that element. And then the element templates are used for those definitions. Another thing that was introduced in this open roads was civil cells. They're really not a cell. They're a collection of civil elements, geometry, templates, terrain models that can be placed repeatedly in a design. So I think that's why they call it a cell, because it can be repeated and placed in a drawing. But it's really not a cell in the sense of an element that you place in the drawing. It's made up of a bunch of different things. And the only way to place a civil cell is you have to use the Place Civil Cell tool. And so those are the different cells that we have that we can use now for 3D placement of an object. Best practices, we've run into I've run into a lot of problems as I've tried to define these and place them. Things you need to remember in your drawings is we cannot have a global origin shift. UDOT seed file used to have a global origin shift. And so if you're using an older project, you need to make sure that global origin is removed out of it and that you're not using that. Always use a generic feature. So if you don't know what the utility is, don't leave the setting as you to place a cell. You're going to place a node saying, I've got an object here, I'm not sure what it is, but I need to connect this pipe into it. Don't leave it on no feature definition. Always select a generic feature, and they have generic features for electrical generic, or always use a generic feature instead of a no feature definition. Your solids area for your cell and for your drawing file needs to be 1 mile or less. And so our seed files have been adjusted to have a solid modeling area of 1 mile. Drainage, when you get into the drainage design, your conduit needs to go from the upstream node to the downstream node. And so that'll be important when you get into the design and analysis part of the SUDA, is make sure you place your cells in the direction that your flow is going to be going. It doesn't matter for the electrical or the gas or anything else because it's not being used for an analysis, but make sure that your conduit's going in the right direction. don't morph the utility. So if you've placed a utility and you say it's an electrical transformer or whatever, you can't decide that that's going to be a storm drain now. So it will allow you to change the feature definition, and it'll look like it's a correct thing, but the database doesn't change. So the behind the scenes of that utility does not change. So make sure if you have to change it, delete that element out and place a new one with the correct utility. Conflict detection may fail in a mixed 2D, 3D model. So they're saying the way the SU works is you'll be placing everything in a 2D view. And when you do your conflict detection, you'll go to your 3D model and do the detection. The program allows you to place, to just have it, well, it allows you to place the SUDA information in a 3D model. If you do that, you're going to have 2D cells and 3D cells in that same model. And that's where this is warning you against that conflict detection. It's not going to be able to discern and find the difference between a 2D cell and a 3D cell. And so always function with the 2D cells where you're going to be placing your information, and then it'll be represented in the 3D that you can do a conflict detection with. So now we'll go to the demonstration. Different things I want to show that the functionality. I want to show how to place a node and conduit, and then how to modify the information, how to enhance the information that's in that model. The use of flex tables. I'll show you that. You can get a quantity. Well, I don't know if you can get a quantity, but you can get a summary of all the elements that you've got placed in there. Show you the utility properties that are available. MicroStation and inroad or power inroads, or most of the Bentley applications have a built-in clash detection. So I just want to show you what the difference, what added features the SUDA product introduces for clash detection. And then how the orient to top surface is an option on placing these SUDA cells. And so I want to show you where you can make those changes in the preferences. And then I'll show you what an iModel, how to create an iModel, what that iModel is going to display, and why we want to use this program for these 3D features. Because in the iModel, it'll give you a lot more information. So let me get out of that. And, starting from scratch, I'm going to create a new file, let you know I don't have anything up my sleeve. But in that, I hope it works. So we'll create a new file. I'll just call it demo. I'm going to make sure my seed file is the 2D seed file. Right now it's the 3D seed file. For those of you that aren't familiar with the UDOT workspace, if it doesn't have an _2D, then it's a 3D seed file. So I need to come in, grab my 2D seed file, and use that as my basis for creating this file. And then we'll go into that. I'm using Power Inroads, the I can't remember what version it was. The 800 series one, the SS4. One thing I usually have, and I don't see it on here, is I usually will pull up in the key-in browser and park that down at the bottom. So coming into the file, we don't know if it has a global origin or not. So what I'm going to do here is do a GO equals. Then you can do a question mark or a $, and it will tell you in the message center if you have an offset. You want this to be a 00. So always check and make sure that your seed file has a 00 offset. If it doesn't, you could do a GO equals 0, 0, and then is that GO or GP? GO 00, and then it'll ask you where's your monument point. And then I'll type in xy equals 0, 0, and then the straight line character that's above the slash, and then UOR for units of resolution or something. I don't know. And that will center your thing. So GO equals 0, 0, and then you would put XY equals 0, 0, and then that shift UOR. So that's what you would type in, and then hit enter, and it'll set up your global origin. Don't want to do that because it's already set. I don't know what that would do to my file if I did that. No, I didn't want to do no tricks up my sleeve, but now I have to attach all my references. So this project is one I grabbed off of it was a design project. It's a passing lane down by Santaquin. It was just a widening project, and I thought it'd be a good one. It had some structures in it, and so I thought it'd be a good one to test. I'm not going to bring in the point controls and the striping, so I'll bring those two in. So I've got my design file and my alignments. This is another thing that we need to establish is what our logical names are now for all these different files that we're having to create. One thing with the coincident world, we're using a projected design now, and this is one of the places where the new inroads will crash on you. If you chose, let me hit cancel. Cancel. I should have had reprojection as an option. So that tells me that this file doesn't have a projection assigned to it. Yeah, so I don't have a projection assigned to it. So I'm just going to go and grab the one from the design file. That one should be good enough. So now I have a geographic projection. This project was before we had projections. So MicroStation allows you to choose control points that have known lat longs. And so I went out and grabbed the control network, grabbed my points, and created, it's called an azimuth equal area. So it's based on 5 or 6 points, known points. It'll try and create a projection for that. And so that's what this file has. Let me hurry and do a save settings so I don't. All right, so now I'll add those files again. So now I have reprojection as an option. If you're in the same projection and you know these files have the same projection, don't choose reprojected, because it adds on more behind the scene conversion and transferring, and it blows up OpenRoads. We've had OpenRoads crash a lot. Since I know these are all using the same projection, choose your world coincident. Let me give it a logical name. Alf. No. And then this is a design file. World. I haven't turned on any nesting. Usually you'll want to bring on nesting if they have 3D files assigned to them. And then I need to bring in my terrain, so let me attach my terrain. I think this one. Okay, so I've got trains and design miles attached. Let me do a file save settings again to save that location. All right, right now we don't have any 3D models that have been created. And so as I go to this SU data, subsurface utility information, you're going to have pull down here. and you'll have the same commands in the task menu for subsurface utilities. And so those are two different locations that you can execute things. I'm going to do most of mine from here. As first thing you need to do when you come in, because I'm using the SUE application, I need to turn on my product. So the subsurface utility, we need to activate the subsurface utility engineering. Notice there isn't an activate hydraulic or the SUDA part, only if you wanted to increase your functionality. So we have an equivalent of StormCAT 100 inlet maximum is already loaded, functioning. If we wanted to increase its functionality, we could do the StormCAT Unlimited SilverStorm. We don't have sewer gems. We don't usually do a sewer design, but those, if you needed the additional functionality, you would choose those. So I'll just activate my SUE license. If I didn't do that before, it would prompt me before I placed a node saying that you need to activate the license. As I come in and place, I can, yeah, a little disjuncted. In components, I want to place a node, and so the SUE information is a node-to-node based design, and so I can't place a conduit without attaching it to a node, and so we're going to have to place nodes first. I just click that I want to place a node. It's saying, hey, this drawing file doesn't have the database built into it. Do you want to proceed with that or not? And it's undoable. So yes, I didn't accidentally hit my button, so I intentionally want to do it. It'll create that database. It's created a new project. For those, from what I understand, for those that are familiar with the Hasted products, this is Hasted built into the drawing. And so they have project information that you can, project properties you can set up. You can give a title of this design, who the engineer is, what company it's for, what date, and any additional notes. So if there's any information about this subsurface utility design that you want to convey to the contractor or anyone else that's using this, you can give project properties into that. So now we'll come and place a node. Make sure on my cheat sheet I'm doing everything. Let me window in on an area. Also let me display, civil data. Let me display my terrain. Expand. So I've got a terrain down here. I want to set it as the active terrain model. Because it's referenced in, I also need in this terrain, I'm right-clicking on the terrain and it's doing nothing. Okay. I also want to go into the properties. It's not going to let me get to the properties. Yeah, if I can remember where that boundary is. Should be out here. It's a fence element. Fence element. That's the train. So if I go into the properties of that, no, see it's not. Let me try one more time from this one. Just disappears when I get down most of the way. I may not park it. Let's see if that helps. Okay. So the properties, what I want to do is I want to come down to the symbology override. So override symbology, and I want to turn that on so that I can come in and turn on contours or triangles. Let me turn on some triangles. I'm doing that because I want to be able to select it as a reference. So now if I come back to my task, let me pin that again. Now if I come to place a node, when you first get the place node option, it's going to prompt you for a reference element. Make sure you choose your utility that you want to place first. So just showing you what's available. These are the generic nodes. So if you don't know what kind it is, you know that it's an electrical node or it's going to be a gas, but you don't know if it's a inlet or a junction box or whatever. Choose the generic node. So don't leave it as no definition, which doesn't look like it's an option. So these are the different things that we have developed so far. We have drainage nodes that have been defined, whether they're catch basins, clean out boxes, or manholes. So if they're catch basins, and I'm going to get rid of these. These are the ones that were generated by Bentley. Bentley took our drawings and created us cells, and then from those I expanded. I didn't want to get rid of them in case something was corrupt in what I had created, but I think we're going to do that. So if you have catch basins, you'll see whether it's in boxes or if it's in gutter. So it's going to have a different top model based on if it's just a drainage box or if it's in a gutter section. And then we have, is it going to be a CB1, CB2, CB9? Those are what I have defined so far. If it's a box, we have CB5, CB9, 7, and CB9, and then all the different options. So let me show you the Bob's world of naming conventions. And if our hydraulics people want to get that changed, we can. We have the CB9, what column and thickness of the wall. So if you're familiar with our drainage standard drawings, we have our columns of your boxes, and then if you get down to a certain depth, it's going to change the width of the wall. And so this application doesn't automatically adjust the wall thicknesses. And so we have to choose if it's a 6-inch or 7-inch or an 8-inch thick wall based on it. So after your design, you're going to come back and change it. You can choose a 6-inch wall at first. It gets so deep, change it to an 8-inch wall after the fact. This isn't considered as a morph. That you're still in the drainage. You're still where you're supposed to be. So you can change the wall thickness. Column B, column C, whether it's a bicycle safe grate or a rectangular grate. Struggling with whether standard, you get rectangular, standard, a bunch of different naming on that. I just chose rectangular because standard is too common of a name. And so you can choose it if you want a CB9. We're going to do column B, 6-inch box is going to be here. It has a default name prefix. You can change that if you want. Give it any name you want. And now it's prompt. So now I'm ready. I've got my feature definition. Now it wants to select a reference element. This is where you would select whether it's a top design or an existing ground. So I chose the existing ground, the topo. I just grabbed a triangle. You could grab a contour. You could grab a feature that's made up of that terrain, anything to orient it. Now it's going to say placement type. Do you want to go based on minimum depth? This is the minimum depth of your 3D cells that you've created. When you create a 3D cell, you want to make it be the size of the smallest box that's allowed. And so these are going to be the smallest depth, the thickness of the top of the box, and then whatever information is in between it. The other option on that is by conduit invert when splitting. So if I say I've got these conduits here, if I wanted to split one of those conduits and place a box in between them, I would choose one of these options. Conduit invert with split. It would cut the conduit and give you an invert incoming and outgoing pipe. The other option is without a split. So if this is a continuous pipe going through, you would do it without a split. Trying to think of where, I think we have a median drop inlet that you puncture the top of the pipe with your And so I'm thinking that's when you would do that, because you wanted the continuous conduit come through, the continuous pipe going through, and then it will maintain that full length of pipe and not cut it in half into two different pipes. So those are our options. We'll do by minimum depth. So you just data point to select it. Now, if you wanted to create a vertical offset, yes?
Well, can you choose by conduit if the conduit's not already placed in the drawing?
No, I don't believe so. I don't know what it would do if you didn't select the conduit.
Once you place the conduit later, can you change the box type and minimum depth by conduit so that it'll adjust the conduit's place?
It will automatically do that. The only difference on that is for existing pipe. So, and I'll show you in here, I can change my conduits and my box will automatically adjust based on my invert elevation of those conduits. So as those conduits are snapped into these nodes, it automatically adjusts the depths that you want. One thing I have noticed that if you dropped your invert and then you decide not to go that deep and went up higher, I think the box is staying down. And so you would have to come into the box and change its invert elevation. It's not an automatic readjust upward, but it will automatically adjust downward, if that makes any sense. So vertical offset, if you wanted to place this 5 inches higher or 3 feet higher than the existing ground, you could do that. Say design doesn't have their surfaces created yet, but you know you're going to be 3 feet higher at this location. I want to put this pipe, then you would adjust vertically. Or if you want to go downward, just to establish the elevation. So unless you adjust the elevation on that. If I leave it at 0, it's asking where I want to place that. There should be, if I zoom in, notice how it's following that surface to give me an elevation. So it's going to be reporting your elevation as you go. It's kind of hard to see, but so I get it where I want. I could have my Civil AccuDraw on so that it would report a station offset, and I could place based on station offset. And so it doesn't have to be a freehand location. Just turn on the Civil AccuDraw and have your option in the Civil AccuDraw to be station offset. Yeah.
This might be a stupid question, but what if you have a corridor that you've created? Do you have to create a design surface for it to recognize that design surface?
Yeah, the question was that if you have a corridor designed, do you have to have a design surface created to be able to pick up that? I'm not sure. They just changed the functionality in this latest release that it's always creating a mesh. They have found that they always, with the corridor clipping and different things, the previous version didn't automatically do it because you didn't have a mesh to tie into. They are automatically creating a mesh every time. So I'm not sure if that functionality is in here now. If you aren't displaying a mesh for your design, whether it'll tie it or not, because that mesh does exist, and so I don't know if that's, I haven't tested that yet. Hopefully they'll be using that mesh. We'll test it here in just a sec. So you're going to place the cell and say, okay, this is where I want. And then it wants to do an orientation. How do you want this oriented? Just read in the help file with this latest release, my orientation is wrong. They don't want the 0 to be the same direction as your flow. I thought it'd be easy to, when I set these cells up, I thought it'd be great to place my cell and then, my curb and gutter's going this way. I can just figure out where my curb and gutter is, and that'd be my rotation. Well, it's saying it wants to be perpendicular to your reference alignment. And so I'll have to change all 200 cells and change their orientation. So that's going to take me a while to fix. But your orientation, you can set it any direction you want. We'll place it here. It will place that cell and automatically jump into a next placement. So you can just keep dropping these cells wherever you want. But it's going to be all based on the same reference. I'm going to reset. So it says select a reference element for elevation. So if it will allow me to zoom out, let me come and grab this design and see what it does for, so minimum depth. We're going to place it, and it seems to be reading it. Yeah, let's place a box here, and let's face it that way. Okay, so now, ooh, looks like I might have clicked twice. Yep, it highlighted both. So it looks like my top cell is facing this way and my bottom cell is facing that way. Okay. All the fun you have here. So because we placed in 2D, we should now have a 3D model that was automatically created in the background. And so we have a 3D model that was created. Let me just go to that. Actually, no, let me go back to the 2D. When you're working in the Suda, it's usually best if you just open up two windows. Have one in your 3D and one in your 2D. So, view. Thank you. So I'm going to tile these. Yeah, thank you. Thanks for... I was looking for the view in the top area. So I've got a 2D and another 2D right now. To change a view window to the 3D model, you come over to the view setup and change the model to be the default 3D model. So now that's in the 3D model. Now I can do my orientation. Let's change it to a isometric. We'll zoom up here. Figure out where I place those. The other thing, let's look at our reference. Notice how it's automatically referenced in some things. So let's look at the references. Make sure that your view with your 3D model is bold. So it automatically brought in the alignment, the design, and the XTopo, the 3D models of that. The XTopo is a 3D file, so it just came in without having to change a model. So my 3D, it automatically picked up my references that were in the 2D and put them in my 3D. I could come in and add another 3D model if I wanted to add my structures to this, or you can treat your different models with different reference information. I have created the 2D plan graphic. I've taken to the width of the box, so it's taken up space in the 2D plan of what the box is going to take up in the 3D. Before, we usually just showed a little X or a square. Our cells were not very descriptive, so I'm changing the 2D cell. From the UDOT drafting, if you went to the hydraulics, and see, I don't think these, so if I did a catch basin, I'm not sure. Let me come back into this file. So it was a profile, so it didn't do you any good to choose a hydraulic cell. But the symbol we had in the drainage wasn't very useful. I think we had one that showed a grate. We have a 2D cell of that. So long story I'm creating new 2D cells to represent the space that's being taken up by the model. Let me see where I'm at in space. I'm up there by the second. So I should have some catch basins in here. Oh, here's one. So when it created the 2D file, so this should be this cell. So Y. Okay. So as I highlight that, it should have highlighted this one. Or if I highlight in 3D, makes me wonder if they're the same cell. If I change, one way we'll be able to tell if it's the same cell is if I change my rotation. I don't know why it's grabbing the, so if I grab, I can change my rotation. Let me change it 90 degrees and see what, okay, so that is the same cell. So you can change your rotation afterward. It's also reporting the top elevation that you should be able to just modify here. If not, go into the properties and you can change your bottom elevation. So if I wanted to drop that down to 5, notice how that 3D cell automatically went down to that invert elevation that I had defined. And so another thing, this oriented top surface, and that's something, no, we'll talk about it now. Oriented top surface, what it does is it's going to try and match your 3D cell to the slope of what you want. The majority of our cells that we're going to be placing, we want them just to be vertical. I don't know of any that we orient to match the surface. And so we'd have to change that to false, and notice how that rotated that top cell. It's only the top cell that gets rotated. And what controls that is up in the workspace preferences. In the view option civil, there's a subsurface utility information that you can change these orient top to surface maximum slope. So if I was in a slope that was more than 15%, it wouldn't have oriented to top surface. I'm going to change that to a 2% slope, because I usually, even then I might not want to do it, but then when I place my next one, if I'm on a slope that's greater than 2%, it won't do the rotation on that. Let me see if I can find my other box. I think it's up here. Don't know why I used the same box. I don't know why it worked here and not on the design. So something in the design surface might have blown that cell up. We'll see what happens when we connect it. So we have 2 boxes in there now. Let's connect them with a pipe. Again, choose your feature definition. This is going to be a conduit. It's going to be a storm sewer. And we've got some options. These all came from Bentley. I don't know. We have a A2000 PVC pipe. We have a circular CMP, RCP, or a smooth line pipe. Let's do a smooth line pipe. It'll give a name prefix. If you don't like that, just change the name. And then you choose in our descriptions, our definitions, we have different pipe sizes. If one doesn't list here, let me know and we'll change it. So we got 12, 15, 18, 21. We should have most of the sizes. Let's just place a 24-inch pipe. This could be changed afterward also. I believe the SUDA application is going to automatically change these. I'm hoping that. I haven't played with that. So hopefully if you're doing a drainage network, it will resize your pipes for you. And so so you set up your feature definition like usual. If I had a specific length or pull or angle, slope angle that I wanted to define on this, I could do that. If not, it's just going to grab the cell. So it wants to know the starting node. Let me make sure I'm in that. So it should automatically detect that there's a node nearby. It's going to grab a connection region, and I'll show you that in the cell definition. We define in these cells where pipes are allowed to tie in and connect. And so in this one I could connect here, I can connect on the side, the back. So I've got the 4 different areas that we can connect into defined. So I'm going to be coming off this side. Wait for it to give you a gold crosshair, and then select it. It is now telling me my length and my slope of that pipe. Let me see if I can find my...
Well, is it the pipe wrapped inside the wall, right? Not outside, right? Inside the wall, the block, right?
It depends on how it's defined. I don't remember how it was defined. And I can't find my box. Is it there? In this area? Upward or? Oh, there he is. Okay. All right, thank you. It's giving me a gold crosshair. I don't know why. Okay, so now it found the box. So I'll click in, and it places the 2D. Let me get out of that application. The other thing that happens in your 2D file is it automatically references in that 3D model. And so let me show you so we're going to be seeing the outside of that pipe and this line that represents the 2D. Usually I think we would turn off the display of the 3D in the 2D file, and so all you would get is the 2D representation. And so the box, so now the 3D boxes, we wouldn't be able to tell in here that we had a problem with this box because the 2D cell is represented here. Notice these little lines here. These are the connection regions that are defined for those boxes. I can work totally in the 2D. If I come into the properties of this pipe, it now tells me my start invert is 4965, so that was the invert that I had set on that first pipe. And then my stop invert is 4974. So I just broke my first rule of doing hydraulic pipes going the direction of flow. I'm not doing a hydraulic analysis, so that's all right. I'm going to change this elevation. Well, okay, so my downward flow, I'm going to send this down to 63. Now it fixed that box. Notice how the box went down to the depth that it needed, and the pipe connects in there. And so all of your manipulations in here can be done in the 2D view, put in your values, and they will be represented in the 3D view. Let me change the view to we'll just go smooth. It should show that box just barely underneath at the surface. So something, I'm not sure if it went to the bottom of that terrain or what terrain it grabbed. We should have seen a box in here. Here's our other box. Notice how it's got the grate. We chose the bicycle safe grate without the gutter. That should be a hollow box, so if you cut it in a profile, it should look correct. Here's our pipe. We had a request that all utilities pick up the color of the utility for our SUE. And so storm drainage is going to be purple. So all of the conduits, gas will be yellow, electrical will be red. So we're not doing any material assignments. We could do material assignments here, make it look like plastic or make it look like our concrete or corrugated metal. We wanted to do the colors based on the utility information. Information on this, let me see. Information that's automatically added to this. I'm having a hard time grabbing this guy. We have the properties that are shown here. It tells you what the feature definition. All right, I just went so deep that I'm going to have to change to an 8-inch bicycle safe. It has a default depth, so the box for a column B in an 8-inch box is a lot deeper than what I've got my pipe. But its minimum depth is where that depth started. So the boxes are gonna define the depth based on those columns. Yeah,
If you increase the pipe diameter, will it change the box width?
no. So the question was is if you change the pipe diameter, will it change the box width? The only thing that's dynamic on these boxes is the depth. So I can come in here, let's do that, let's change it to a 48 inch. It'll change the pipe. It looks like that might still fit it, but let's go 60 inch. How about 72 inch? See, now it's gotten bigger than the box. So the box doesn't automatically adjust. So I would have to come in and choose that box, change its feature definition to, was it the CB, would an H handle it? Oh, the H was a deeper box. That's another thing that I haven't developed, and I'm not sure. The orientation, so the columns are coming outward. So I could have easily tied into the side of this box with a 72 inch, but my front is staying the same width. I've seen some designs where you're rotating the box and the grate, but that's not in our standard drawing, so I didn't create it. But I think we're going to have to create all of those different type of boxes where the grate here is rotated on this side of the box just to accept it. CB10 does that? Okay. So I need to get those CB10s defined and put in. Heard some clapping, I got panicky.
Hey, Paul, can you clear up something for me real quick?
Uh-huh.
So, usually, you have an engineer define space between the bottom invert elevation and the bottom of the box. I noticed that when you clicked on that, you went to the properties, it said bottom of box. Is that the bottom of the box, or is that the very bottom?
Yeah, so the question was that invert elevation, is that the very bottom of the box, or is that that is defined in the cell definition of where we say this. So let me go in, let me show you the MicroStation. So I've got these cells, so this is a top cell. There's a graphic here, this purple, let me grab. You define where your top elevation is on these 3D elements, so this element here that I've got highlighted defines what the top elevation. The box is still taller than where it is, but this is going to be my top elevation. This is the elevation that's read and input into that. So
Is that the station you call out point also?
it could be so the question was, is that the station call out point also? It is right now. I believe we're calling out our box locations based on the back wall, not the center of box. The latest plan sheet development standards did that. So I've got that as my station offset location. I could have the station offset location at the center of box. It's just dependent on, notice how I have two graphics that were called out. One is the call out location and one is the invert elevation. So there's two different lines, points defined in this cell that says this is how we use this. If I switch to a bottom box, let's go to this one. Oh, good, I don't have the rendering here. So here we're calling the call out point is this red point, and our invert elevation is the purple point down here. So I've got defined the inside bottom as the invert elevation. Now, if we had, can't remember what they call it, if you're pouring concrete up the side, and so the bottom of the box is a little higher than the invert, that could be defined also. So it depends if it's not a sump situation, it's, what is that? a formed invert. So if you wanted a box that had a formed invert, we would put that flow line, that bottom elevation, a little bit into that concrete, and that way you would get that defined. So it's all on how we place these points. There's also a line, you can't see it, there's a line here. This is the orientation line. So I need to go into all of these cells and rotate that 90 degrees so that it's in the right orientation.
What if you had a few boxes that had to have that red point placed on the other wall? The wall facing to the right?
Uh-huh.
Because maybe it's in a ditch and you need it centered, not on that wall, but on the other wall. You want it centered on the grade. Are we able to change that call-out point box by box, or is it by feature, is it all or nothing?
Yeah, the question, I'm repeating questions so that the training can relay that. The question was, can we change that orientation after, or on an as-needed basis? Yes, you can, but the only way to do it is copy these models and create your own and change that orientation. So and you're welcome to do that in any project. Grab our standard, modify it to how it needs to be done on your project, and then implement that for your project. And so, yeah, change them. You can create your own 3D cells to be how you want them to be defined. If we have a lot of that goes on, that it's used all the time, let me know. I'll pass it to Jeff and Rob and all those guys, and we'll get it incorporated as a standard. And so we don't want you to have to keep creating your own things for UDOT projects. We want to be able to create those standards. And so this is where this is defined. Those connection regions are these shapes. I could have this shape be the entire width of the inside. Also, those are pulling, the location of these shapes is how long your pipe's going to be, how far you want that pipe to go into your box. So if all pipes came in 3 inches, I could move this back 3 inches and the length of your pipe would come into the box, those 3 inches. And so that location is defined based on this region. I could have this shape be any size. Manholes where you can connect anywhere, you just define a cone, and you can tie in anywhere into those manholes. So that's the cell definition. Then the 2D is just 2D graphics. So that's how these are defined. I wanted to show you the capability of this SU. Why I want to use this SU in our projects. The box has information in it. So automatically when you create an iModel, the information that it's a CB9H box is in there. It's going to tell you where it's based on for elevation. Contractor, if he finds a bust in your surface, he knows that you actually wanted this to be ground level, and so as he surveys that new ground or changes the existing ground, he can adjust the invert to be based on what your design intent was for that box. It wasn't a fixed elevation, it was based on the surface. Surface is wrong, different from what we provided you, we'll place it at that surface. Different things like that, it gives you the rotation. Utility properties, we've got information in here that gives you what you've seen there before. You come in and tell what quality level. So if you've got some representation of electrical lines or gas lines, you can come in and say, hey, this is a level B. We're pretty certain that it's there. What's the investigation level? It was an engineering, informational, or land survey. It was surveyed in. So information that you can put in here, what kind of material it is, you could input that information. It gives you the length and width. I don't believe these values, but those are information that's put in there. So we're going to be conveying all of the information to the contractors through these cells. It's an inherent attribute in here, and this is a way to convey that information to our contractors, just based on a 3D. He or she could select that element and get information that they need for construction. Same with the pipe. It's got its properties, its utility properties. What's the scaled length, what's the quality level, again, it's a stormwater only, it's a trunk line, it's a circle 72-inch pipe. All of that information is embedded in the graphics. Flex tables, a functionality of this being a database is the flex tables. You can come in and grab. So if I had a lot of features in here, right now I just have the 2 nodes. It tells me, so I made that change that is a quality level B. That's portrayed in the flex tables. You can export these flex tables out to an Esri shape file, a tab delimited file, or a comma delimited file. So output of this information, you can send it into other applications. And then I'm going a little bit faster because we're 5 after. You can add what you want to display. So right now the selected columns that we want to display are here, and these are all the options that we can add. So if you wanted the owner information to show up in that flex table, we could have that, and you could put the owner information in there. Yeah?
Can we create our own attributes to display?
The question was, can we create our own attributes to display? Yes, it says so in the literature. No, I haven't figured it out yet. If you notice in that edit table, there are user-defined element type, user-defined network type. There are ways to add that, but I haven't figured it out yet. So the functionality, Bentley says yes. Bob hasn't figured it out yet. So if you've got it figured out, let me know. We can enhance the information in these projects with that additional user-defined information. So flex tables are powerful. You can also do a report in XML. So you have different ways that you can export information. I don't know if I dare. Okay, so here's the XML report that's created from that you can output. So flex tables, the information that you're placing in these drawings, you can report it out. I wanted to also show you all the different, let me close out the flex table, all the different feature definitions of what we have. I showed you the boxes, whether in the gutter or in a box. Those were the drainage ones. Electrical nodes, we have a service pole, have a power pole. What the difference between those are, I think service pole is next to is just a straight pole. I was doing the I-215 project. I was playing around. I do a lot of my playing on the I-215 projects. They're trying to implement all this, and they have some power lines along 47th South that the LiDAR picked up the graphics, and so I just take those graphics and say make them electrical line conduits, and I've got my information there. Well, my power pole is just the normal street power pole with a 2-line, 2 crossbars or whatever. So that's my 3D representation. Well, these are towers. These are main trunk lines. And so I've got my little power poles down here, and my wires are strung up here. So 3D representation is, we need to create all of these different features to be able to represent accurately what we have in here. And that's another question. Do we need to represent accurately, or just a representative? Does my fire hydrant need to look like the fire hydrant that West Valley City puts out compared to Syracuse City? And, or do I just have something that looks like a fire hydrant? So those are all the questions that we have in these applications, our 3D representations. What do we have on those? Head walls, we have concrete head walls, flared end sections, L-shaped, straight, 12-inch, 18, so you have a bunch of different head wall options. Metal head walls, the flared end sections, safety end sections. These are not UDOT standard drawings. These are Bentley's provided to us. So heads up on that. If you're looking for an exact, these are just graphical representation that Bentley had generated. I threw them in just to give us something to start with. Lighting, we have our light control center, high mast. Again, these are from Bentley. Notes 3D, well, let me go on. They have pond outlet structure. That's a Bentley. Utility conflicts. When we get into the clash detection, one thing that the SUDA provides to us is it can place a cell where you have conflicts. So wherever it found a conflict, it'll place a node there. Well, you can go and grab those nodes and change them to whether they're completed, where a bore pit is needed, if the conflict has been resolved. So we have different states that we can change those cells to represent. So the contractor comes in, he says, oh, they had a utility conflict here, it's been resolved. Or they did a bore pit at this location, it looks like everything's resolved on that. So the conflict resolution, we can get 3D cells in there to show those. Utility nodes, we got gas meters, valves, petro. And then water nodes, we have our fire hydrants, our water meter, water valve. And then where I'm going beyond what Bentley intends us to do is with this Nodes 3D. I have signals, I have ramp meter pull, if it's one vehicle per green, or if it's a 2-lane ramp meter, or if it's a 2 vehicle per green ramp meter. And also signing. I don't have them all in here. We got a 3-inch P6A, left or right side. The cuts had to do in the left and right because the snap points, the angle is different, whether it's a left or right in that standard drawing. So I had to create 2 different there, or if it's a P1 sign. So I'm going a little bit beyond what the functionality for utilities. I'm going into more 3D and use of on the 215 project, there was a bunch of cells created for barrier. I don't have those in here yet, but they had done a 2D representation of 3D so that you can click on your top surface of concrete and place. These were the transition barriers and different things that have a unique pay item assigned to them, just as options that are available. So underneath Nodes 3D, it'll be all the UDOT specific things that we're just flooding in beyond the utilities. Properties, we showed that. Clash detection, let me show you what the difference between the clash detections are. Bentley has clash detection built in. So you don't have to own SUDA or anything to do this. You would create a job. All the clashes are based on level or references or item sets, name groups. So you can do clashes, say, grab all my existing utility gas, compare them against my storm drain, and it'll give you the clash detections. You can set up rules, you can set up clearances, soft clearances around those. So that's the microstation clash detection. The SUDA clash detection, if I can remember where it's at. No, I didn't highlight it. All right, analysis. Nope. All right, it's in here. Oh, okay. Okay. You see what your mind tells you to see, and it's not the same as what's being shown. So in this utility conflict detection, and the reason why it's not highlighted is because I'm in a 2D view. My 2D view is highlighted. Let me switch to my 3D view, and now this will activate. So I can choose by level. So if I have everything on, if I went down to the XUT, so I can grab all my XUTs and say I want to check these. No, so it doesn't allow me to grab a group. So you have to do one at a time, drag them over, place it. So you can check based on level, or I can say check my catch basins. Check all of these. So the functionality that SUDA brings in is you can grab your features and say, check these features against these features or levels and add all that. You have your clearances that are allowed. You can do a trench. So if I have a utility that I'm designing that has a trench built-in template, I can have it check that trench. Is my trench going to be impacting any utilities as I place this utility? And so those are different options that you can do to test again. Global options, you can your tolerances. If you want to base it on a terrain, feature definition, what you want to use for your clash detection. So those are the added functionality that this does. It'll place a ball where there's conflicts. Those balls can now be reported in the flex table. They are a 3D, they're a SU entity, a node that can be reported on, its conditions and different things. So a lot of good output from those. So iModel. So I'm going to fix this pipe first. For some reason, it jumped its location. So I'm going to connect it back in here to the front. So you can grab your pipes, change them to locations. Maybe this pipe needed to go to some other box. You can change your boxes that way. My pipe should have a center. If I wanted to place a curved pipe, it allows you to do that. I can generate a profile of this pipe also. Let's go down to 3. So here's my boxes. Notice how my pipe is a little bit higher than my box. And so I can change my profile of this pipe through through profile definition. So a lot of functionality on the design and placement of these nodes. So an iModel. So if we wanted to create an iModel of this, we'd go to the MicroStation, publish iModel. You want to save changes, so it wants to know is your database saved. Let's save it. I'm going to create a single package. It automatically picks up the name of your file that you're in. If you wanted to change that, something different, I'm going to cancel because I forgot to do something. If you're going to be doing an iModel and it's going to be used on a tablet or the new Navigator Connect, you want to create a saved view in your drawing. I'm just going to create a couple. This is an ISO. Let me, it's either under here or Tools. Saved views. So I've got this as my active view. I want to capture a new saved view. I'm just going to call it 3D ISO. And click the view that you want to save it. If I wanted to come in specific for that box that I created, I want to call attention to something, I can create a saved view of that bad box or whatever you want to, if structure or a joint or, anything you want to capture in there, you can do that. So my bad box was created. So now I've got some 3D saved views. If I want to do some saved views here also, I could do that. So I don't have to just have 2D, but the mobile apps are only going to pick up the add 2D. It'll only pick up the 3D files. So now I've got some saved views created in here. Let me do a save settings. I'm not sure if that's required or not. And then publish iModel. For right now, this is how we're going to convey information to the contractors is through iModels. We're investigating a bunch of different other options. This is Bentley's solution for conveying information to contractors. So we're going to create a single, if I wanted to change that name, I could give it, Plan Enhance, or, whatever you want that package to be. Protection, if you want to, you could give a password protected or certificate protected, or allow everyone. You can choose whether they can export information or print the information. Whether you want to remove intermediate files, these are files that are created as it's publishing. Sometimes they're good to keep, so you don't have to recreate them each time. It makes your process a little bit faster. And I don't know if you noticed that when I was selecting files to import for references, I had already gone through on this project knowing that creating an iModel takes a while. I've already created some IDGNs, some iModels for all of my intermediate. Since this was a new file, I don't have any iModels created for the demo. And so that's where the intermediate, I want to create an iModel. So this is where there's a different, it's going to create an IDGN, which is an iModel. If you want to go out to publish it for like an iPad or something, you want to create an iModel, an .imodel file. The new Bentley Navigator Connect version uses the iModel file. I wish they had changed their names on them. So everything's an iModel and different names. I can republish all the iModels if I wanted to make sure I have the latest information. Bunch of different options here if I want to hide the visible edges or whatever. And so I'll just publish it. It's going to be running. If I had a wider screen, we could see its progress. It's having some problems with some civil objects. Yeah, so we just have to, so it's telling you when it encounters errors. So usually when it encounters errors, it's based on that extra database information that's causing a problem. Now it's creating the .imodel file so that we can open it up in Navigator.
Hey Bob, I have a question while that's running.
Uh-huh.
The biggest issue I have is different suit companies give me different deliverables. Nobody is doing it the same. We have the regions and PMs and maybe requesting a little bit different things. Why don't we have a document that is very specific about what our deliverable is and it's not the same? For example, I get a data sheet from somebody.
Yeah.
Others give me a weird spreadsheet.
Yeah.
Others give me a beautiful model, and well, one is giving me this, and that was wonderful. Why don't we request of all of the suit companies that they give us this,
Yeah.
instead of giving us these little random data sheets?
Yeah. Yeah. The question is why are we getting all different kind of information from the SUE companies? Some are given spreadsheets, some are given text, some are given, I've seen shape files delivered. Some are starting to deliver in this SUDA application. The question is, why don't we have a standard? We are developing a standard. That's what Richard Manser is working on, developing that 3D database, where they're going to develop standards that we need to receive from the utility companies. It'll come in. That's another thing that's part of this SUDA. Let me look at my errors here. Okay, so it's got some errors and it creates a log file. Part of the tools in here is this, what's called Model Builder. That's where we're going to be using to grab from Richard Manser's database and importing and getting the existing utilities into our drawings. So we will set up some mapping and different things that will take a GIS mapping, grab it from the Oracle database, bring it into our drawings. That's probably a good 4 years out. They're starting now to develop, they've got the database developed, now they're developing the input requirements, the requirements from construction. If, you know, as we're constructing and we're shooting survey elevations, how does that get put into this database? So we're starting to grab all that utility, and I think that will solve it. But in the meantime, we really don't have any requirements. Start requesting from your supervisors that you want a SUDA drawing,
Or iModel.
an IMA. No, I would request the DGN file.
Okay.
Just because then you have the raw data. An iModel is always going to be read-only. You can't change anything in an iModel. They might prefer to give you an iModel, that way they know you're not changing their data. Let me open up this with Navigator Connect. Let's see if this will come up. Looks like I have 3 minutes. And hopefully we can show why we want to use this and how it benefits the contractor. This Navigator Connect has only been out like a month. It's their next generation of software. We will, I believe immediately after this, we've got some Connect. We've got Bentley here showing us the Connect programs. They're major changes, and that's why I wanted to, we're not ready to deploy them yet in the department, but there's such a change, we want everyone to have a heads up, prepare. Doom, you know, I don't know. So it's going to give you options. Oh, nice. We won't see it. Anyway, in this Navigator, it will display, you'll select an element and it'll show you all those properties that we were seeing before of your utilities and your pipes. And so it's a great way to convey the information out to the contractor. I wanted to show you the Navigator Connect because it's a lot easier to use than Navigator was. I always, with the Bentley Navigator previous versions, you had to know MicroStation to be able to operate it. It was so close to, well, even if you knew MicroStation, it was hard to run Navigator because they changed things around and it just made it hard to figure out. But this new one is a little bit more intuitive and easier to use if it runs. And so that's how we're going to convey that information. Any last minute questions? Anyone have any? Time to wake up. We got an hour and a half nap, so thank you for coming and thank you for being here. If anyone needs, you're out of state and you need a engineering credit, come on up here and we got the forms up here. All right, thank you.